So I have a few series here that I want to show convergence or divergence, and I'm going to talk about what test I'm going to use and why. So this first one here, I have 100 to the k over k factorial. I'm going from 0 to infinity. Anytime you see a factorial and an exponential, it's a really big hint that you're going to use the ratio test. So the ratio test, we get the limit as n goes to infinity. You can use the absolute value, but it turns out this is going to be positive anyways. And it's going to be a sub n plus 1, so 100 to the k plus 1 over k plus 1 factorial times the inverse, or 1 over a sub k. So k factorial over 100 to the k. Now there's always going to be a bunch of simplification you can do in these cases. So a couple things you need to remember. Well, first off, k plus 1 factorial is the same thing as k factorial times k plus 1, because that's the product of the first k integers times k plus 1. 100 to the k plus 1 is the same thing as 100 to the k times 100. Alright, so these are some simplifying things that are going to help us out here, because now I can cancel the k factorials. I can cancel the 100 to the k's, and these were rewritten, so what I get left with is the limit as n goes to infinity of 100 over k plus 1, which as k, not n, which as k goes to infinity equals 0, which is less than 1. So this guy is convergent by the ratio test. We do have an exponential in here. But before we go run and use the ratio test, one thing you might want to notice, ratio test would work, but there's going to be a quicker way. I can rewrite this as k equals 1 to infinity, and I can rewrite it as 2/5 to the k, since they're both raised to the k power. What I have now is a geometric series with a common ratio less than 1, so this is convergent by geometric series. And not only do I know it's convergent, I'm going to be able to find its sum, because it's going to be the first term. So plugging in 1, my first term is 2/5 over 1 minus my common ratio, which is 2/5. So I get 2/5 over 3/5, or 2/5 times 5/3, and we get a sum of 2/3. So remember, if it's geometric and converges, we can actually find the sum. We don't just know that it converges very quickly and easily. Last one here, I have k to the third minus 1 over k to the fifth plus 1. I'm going to look just at the lead terms, and k to the third over k to the fifth reduces down to 1 over k squared. So if I look at that series 1 over k squared, I know that that's a convergent series by the p series. So what I'm going to do is I'm going to do a limit comparison test. So limit as k goes to infinity of the ratio of those two. K cubed minus 1 over k to the fifth plus 1 all over 1 over k squared. So first thing I'm going to do is multiply by that reciprocal. And that's going to give me limit as k goes to infinity of k to the fifth minus k squared over k to the fifth plus 1. We could use L'Hopital's 3 times to get rid of these terms, and we'll see that it'll cancel. But from what we know of rational functions, this rational expression has a horizontal asymptote if we were to graph it. So we know that this limit is going to equal 1, which is a non-zero finite number. So our original is convergent by the limit comparison test.